Before I begin this 7.3 Rational Exponents Day 3 video, I just want like you guys to write down or somehow kind of come up with a way to remember these important numbers at the top. Those are my perfect square numbers, which I'm going to be referencing quite a bit in this video, and if you are confused by this, you got to go back to the last video and watch that one. That's where we explain most of this stuff with the perfect squares and simplifying radicals and stuff. We're just getting a little bit more complex in this video than we did on the last one. So again, if you're having a lot of trouble with this, I would just go back to that last video and watch it one more time. Okay. Our learning goals are to evaluate and rewrite expressions involving rational exponents, and then we're going to solve equations involving expressions with rational exponents. The first three are all using a calculator to solve. If you have a calculator handy from one of the school ones especially, this would be something that I would try doing. But I've got the answers listed here so you can check your work, but seriously practice them and see if you can get these. Okay, let's move on. I don't know why this is numbered wrong, but it's going to number 8 right away now, so we will start there. It says simplify. Well, if I know my perfect squares, and I'm not going to go up and I'm not going to reference these every single time, so this is why it's important for you to have them written down. But 121 is a perfect square, and it's exactly 11 when you square root it. I meant 11, not 111. So 11 is a perfect square. And then we've done problems like this in the past 2 videos ago, where we are taking m to the 8th and we're square rooting it, and all we did was we converted it to an exponent, so this would be m to the 8 over 2, and then we simplified that to get m to the 4th, and that is exactly our answer for this number 8 question right here. For number 9, we actually have to simplify this 48 because it's not a perfect square by breaking it apart. So a perfect square that goes into 48 would be 16. So I'm going to split it up and I'm going to put it as the square root of 16. And 16 goes into 48 3 times, so I will split it up that way. And then we have y to the 6th as well. And this is how I like to do it. I like to split it into as many little radicals as possible, just because I think solving 3 little problems is going to be a lot easier than solving 1 really big problem. So with that in mind, the square root of 16 is 4. The square root of y to the 6th is y to the 3rd, because 6 divided by 2 is 3. And then I can't do anything with the square root of 3. And now I chose to put that last because typically when you finish your answer, you have to put that root at the end. So that's why I chose to do that one at the end. Number 10, I know that 25 goes into 150 and 25 is a perfect square. 25, so I'll put that here, goes into 150 6 times, and we have p to the 4th hanging out in its own square root symbol as well. So this would be a 5. Square root of p to the 4th would be p to the 2nd, and then the square root of 6 goes at the end, and I just put that at the end again one more time because it's not solvable. The square root of 6 you can't simplify anymore, so that's just going to have to stay there. Number 11, if I split this up, I've got 149 goes into it. Or I'm sorry, 49 goes in. That's what I meant. 49 is a perfect square. 49 goes in 3 times. So the answer to this one would be 7 times the square root of 3. Number 12, 27. I know 9 goes into 27 3 times. And then I'm splitting it up with the a to the 10th and the b to the 8th as well. My final answer will be, well, I can do the square root of 9 as 3. I can't do that one yet, but I will do the a to the 10th, which would square rooted would be a to the 5th, and then b to the 4th after the square root. And I'll put my root 3 at the end. Number 13, that 4 is just going to hang out for now. We will split that square root of 48 up into 16 and 3 again. And then n to the 2nd will go there. So we'll have 4. I'll simplify that square root of 16 into a 4. The square root of n to the second can be simplified to just an n because 2 divided by 2 is 1. And then root 3 just gets to hang out. So we'll have 16 n root 3. Number 14, I've got numbers written down for these already just because I wasn't going to be able to do these in my head. But the fourth root of 625, if you type that into your calculator, you'll be able to figure that out. That is 5. If you're having trouble typing that into a calculator, make sure you let somebody know. But it's the fourth root, not the square root. So you just got to be careful with that. So I got 5 for that, and then 8 divided by 4 would give me 2, so we would have w to the second to finish that problem out. The fifth root of 7,776 is a 6, and that leaves me with a w to the 7th power because 35 divided by 5 is 7. The third root of 3,375 is 15, and we will be left with p to the, well, let's see, 81, I believe that is 27. Yeah, there we go. That is it for that lesson.